Welcome back. For your do now, you had the exact same scenario. So we're talking about walking and the speed that they were walking, and it asked you two different questions. First, it wanted to ask you about your total miles, and then it asked you about how many hours it would take. But it was the exact same problem, the exact same equation that would help you get both answers. So today, that's what we're going to be doing. You're going to be using the exact same equation or scenario to figure out different, values or different answers. So how did you know it was different when it talked about miles versus hours? Well, what did they tell you the first time? She walked 3 hours. So when you were solving, you knew that the hours, the H was 3. You actually use substitution to put in 3 for hours. And then in the next one, it said 17.5 miles. Where did you put that? You put it in where the miles would be, where M would be. And then you solved. So you're actually going to be using substitution, and it will always depend on where you're going to put that value or whatever they give you, either for the independent variable or the dependent variable. You are going to figure that out from context, and then you're going to solve, and it's going to be super fun. So our key point for today, please make sure that you're writing this down, turning in your notes every single day. When using two variable equations to solve real-world problems, we must substitute the given value for the matching variable. So they will give us something, and we're either going to substitute it for our dependent or our independent variable, and we have to figure out which one it is. All right, let's look at our example number 1. Our example is a little bit tougher than what I'm going to ask you to do by yourself, but this type of problem is exactly what they like to put on SBACs, on the MAP test, on any type of big test to see if you can apply, if you understand how our equations and solving works in the real world. Okay, so let's go step by step. Michelle makes jewelry boxes containing drawers of equal size. The numbers of drawers in 3 different jewelry boxes and the corresponding total volumes of the drawers are shown in the graph below. Write an equation representing the relationship between number of drawers D and total volume V. So they already gave us our 2 variables, drawers and total volume. Which one is my independent and which one is my dependent? Do my number of drawers depend on what volume I have? Or does my volume, the inside, depend on how many drawers I have? Well, if I have more drawers, I'm going to have more space inside, right? So my volume, my inside, depends on how many drawers I have. So my total volume, I'm going to box that, is going to be my dependent variable. My number of drawers, I kind of get to decide, right? You go to the store, you're like, I want 3 drawers in my cupboard or whatever you're going to buy, or 2 drawers or 1 if it's a nightstand. So that is my independent variable. Number of drawers, IV. Okay, that's always my first step, finding my 2 variables. Now let's look at my graph. Yesterday, you learned about graphing it yourself. So if you remember, our X is always our independent and our Y is always our dependent. So as you can see, our total volume is dependent, good, and our number of drawers is independent. Very good, we found it, we're good. Now it's asking me to write an equation. So an equation I know I will have to figure out how do I get to my total volume. And I'm going to create a small little table here just to help me out. So my total volume is going to be my dependent, and my independent is my drawers. It's my D. So when there are two drawers, it looks like, oh, I'm not quite sure what that is. I'm going to use the one that they do give me. They give me the pot 3 drawers is 7.5 in volume. So I want to figure out how will I get my answer of volume something times D, right? Because if each drawer is the same size, then if I add 3 drawers up together, I will get 7.5. I can figure out what one drawer would be. So let's see. One drawer, that's what I want to figure out. Ooh, this is like our ratios, right? Thinking back to when we were in school together. If I want to figure out what one drawer would be, I would just divide by 3. Divide by 3. So 7.5 divided by 3. 3 goes into 7 2 times. 2 times 3 is 6. So I'm left with 1. Bring down my 5. I cannot forget about my decimal right there. How many times does 3 go into 15? Well, 5 times. 5 times 3 is 15. I'm left with nothing. So one drawer has a volume of 2.5. Do they tell me the units? Yes, cubic inches. So if each drawer is 2.5 cubic inches, then I can figure out the volume for any number of drawers because my volume will always equal 2.5 D. Because no matter how many drawers I have, they will always have a volume of 2.5 each one. So if I just multiply it, I will get my total volume. All right, now that I have my fancy equation, let's move on and look at B and C. I will write my equation up here just so I don't forget it. All right. Determine the number of drawers in a jewelry box with a total volume of 22.5 cubic inches. So what did they tell me? What was the given information? The total volume. Which variable does that match? Does that match my V or my D? My V, it's my volume. So if I use substitution, then it's going to be 22.5 equals 2.5 D. Now you guys are very good at solving these types of equations, finding their missing number. So let's go ahead and do that. If this is multiplying, if I multiply that times that to get my total, I can work backwards to figure out my variable. So what is the opposite? What is the reciprocal of multiplying? It's dividing. So I'm going to divide. Ooh, why don't I have a decimal there? I switched it, right? I shift them all to the front. Don't worry about my decimal because I can shift both of them up 1, multiply both of them times 10, and then I get rid of my decimal in both, which is awesome. And now I'm left with 25, which is a really easy number to use because it's like a quarter. So 25, how many times does that go into 225? Well, let me think. 25 goes into 100 4 times. 25 goes into 200 8 times. So I'm already at 8. Let me try 9. 9 times 5 is 45. 9 times 2 is 18 plus 4 is 22. Oh, there we go. I guessed it. So how many drawers will have a total volume of 22.5? 9. 9 drawers will have a total volume of 22.5 cubic inches. All right, let's try the next one. Determine the total volume if there are 6 drawers. What did they tell me now? What was my given information? 6 drawers. Now, is that going to match my V or my D? Drawers, D. It's going to match how many drawers I have. So this right here is going to be my independent variable. So volume equals 2.5 times 6, right? Because if I have 6 drawers, I have to multiply that times 2.5, which is each drawer, to get my total volume. Let's go ahead and solve for that. All I have to do is multiply, easy enough, 2.5 times 6. 6 times 5 is 30, 6 times 2 is 12, add that up, 150. Wait a second, something's wrong, it can't be 150. I'm missing my decimal, so if there's 1 behind the decimal here, there should be 1 behind the decimal here. My volume will be 15 cubic inches. All right, I want you to notice that I used the exact same equation. I just substituted the number they gave me to a different variable, but I could still solve. So I hope you'll have fun figuring out the missing variable. That's always so fun for me. I can't wait to see your exit ticket, and I also can't wait to see you at my office hours today. All right, good luck.